Aurdino Education Society, redefining excellence.
Hello everyone, this is the micro project of subject Emerging Trends in Electronics ETE with subject code 22636. The title of micro project is Automatic Temperature Regulator Circuit. The group members are Naik Prathamesh Ganesh, Khan Imtiaz Firoz, Khalse Mari Sriram. We have completed our project under the guidance of Professor S.N. Navle ma'am. Aim. The aim of the project is to build or develop automatic temperature regulator circuit using Arduino Uno. Introduction. In this project, we are going to construct a couple of simple Arduino-based automatic temperature controlled DC fan circuits which will switch on a fan or any other gadgets connected to it when the ambient temperature reaches a predetermined threshold level. We are going to utilize DHT11 sensor and Arduino for this project. What is Arduino Uno? Let us see. The Arduino Uno is an open source microcontroller board based on the microchip Atmega 328P microcontroller and developed by Arduino.cc. The board is equipped with set of digital and analog input-output pins that may be interfaced to various expansion boards and other circuits. The board has 14 digital I/O pins, out of which 6 capable of PWM output, 6 analog I/O pins, and is programmable with the Arduino IDE, that is Integrated Development Environment, via a Type B USB cable. It can be powered by the USB cable or by an external 9-volt battery. Through it, accept voltage between 7 and 20 volts. It is similar to the Arduino Nano and Leonardo. The hardware reference design is distributed under a Creative Commons Attribute Share Alike 2.5 license and is available on the Arduino website. Layout and production file for some versions of the hardware are also available. The word Uno means one in Italian and was chosen to mark the initial release of Arduino software. The Uno board is the first in a series of USB-based Arduino board. It and version 1.0 of the Arduino IDE were the reference version of Arduino, which have now evolved to newer releases. The Atmega 328 on the board comes pre-programmed with a bootloader that allows uploading new code to it without the use of an external hardware programmer. While the Uno communicates using the original STK500 protocol, it differs from all preceding board in that it does not uses the FTDI USB to serial driver chip. Instead, it uses the Atmega 16U2 programmed as a USB to serial converter. The microcontroller is microchip Atmega 328P. Its operating voltage is 5 volt, input voltage is 7 to 20 volts. Digital I/O pins are 14, out of which 6 can provide PWM output. It has one UART, one I2C, one SPPI, 6 analog input pins. Then DC current per I/O pins is 20 mA. DC current for 3.3 volt pin is 50 mA. It has 32 KB of flash memory, of which 0.5 KB used by bootloader. It has SRAM of 2 KB and 1 KB of EEPROM. Its clock speed is 16 MHz. Its length is 68.6 mm. Width is 53.4 mm. Its weight is 25 gram. Its general pin functions are LED. There is a built-in LED driven by digital pin 13, which when the pin is high value, the LED is on. When the pin is low, it is off. Next, VIN. The input voltage to the Arduino board when it is using an external power source, you can supply voltage through this pin, or if supplying voltage via the power jack, access it through this pin. Next, 5 volt. This pin output a regulated 5 volt from the regulator on the board. The board can be supplied with power either from the DC power jack, the USB connector, or the V-in pin of the board. Supplying voltage via the 5 volt or 3.3 volt pin bypass the regulator and can damage the board. 3.3 volt supply generates by the onboard regulator. Maximum current drawn is 50 milliampere. IO-REF. This pin on the Arduino board provides the voltage reference with which the microcontroller operates. A properly configured shield can read the IO-REF pin voltages and select the appropriate power source or enable voltages translators on the output to the work with the 5 volt or 3.3 volt. Reset pin. Typically used to add a reset button to shield that blocks that one of the board. Each of the 14 digital pins and 6 analog pins on the UNO can be used as an input or output under software control, that is, using pin mode, digital write and digital read functions. They operate at 5 volt. Each pin can provide or receive 20 milliampere as the recommended operating condition and has an internal pull-up resistor of 20 to 50 kilo ohm. A maximum of 40 milliampere must not be exceeded on any I/O pins to avoid permanent damage to the microcontroller. The UNO has 6 analog pins labeled A0 through A5. Each provides 10 bits of resolution. By default, they measures from ground to 5 volt, though it is possible to change the upper end of the range using A reference pin and the analog reference function. In addition, some pins have specialized functions such as serial or UART. Pin 0 and 1 used to receive and transmit TTL serial data. These pins are connected to the corresponding pins of the Atmega 8U2, that is USB to TTL serial chip. Next, external interrupt. Pin 2 and 3. This pin can be configured to trigger an interrupt on a low value, a rising or falling edge, or a change in value. PWDM. Pin 3, 5, 6, 9, 10 and 11 can provide 8-bit PWDM output with the analog write function. SPI. Serial Peripheral Interface. Pin 10, 11, 12 and 13. These pins supports SPI communication using the SPI library. TWI. Pin SDA, that is A4, and pin SCL, that is A5, supports TWI communication using the wire library. AREF, that is analog reference voltage for the analog input. The Arduino Uno has a number of facilities for communicating with the computer. Another Arduino board or other microcontrollers, the Atmega 328 provides UART TTL serial communication, which is available on digital pins 0 and 1. And Atmega 16U2 on the board channel this serial communication over USB and appears as a virtual COM part to software on the computer. The 16U2 firmware uses the standard USB COM driver and no external driver is needed. However, on Windows, a INF file is required. Arduino Software IDE includes a serial monitor which allows simple textual data to be sent to and from the board. The receiver and transmitter LEDs on the board will flash when data is being transmitted via the USB to serial chip and USB connection to the computer. Software serial library allows serial communication on any of the Arduino Uno digital pins. Main content. This project can be used where internal temperature of circuit need to be stabilized or saving it from overheating. We are connecting a CPU fan as output. This setup can be used to control the internal ambient temperature of an enclosed circuit. When the threshold temperature is reached, the fan turns on. When the temperature goes below threshold temperature, fan turns off. So it's basically an automatically process. This is the program code of our project. Objectives. As soon as temperature of the surrounding increases beyond 25 degrees Celsius, that is, we can change this value in program according to our need, explained in working section. Motor starts running, and with each degree of rise in temperature, speed of motor also increases. Motor runs at its top speed as soon as temperature rises to 40 degrees Celsius. Advantages. It is very economical and easy to handle. Motor fans run automatically so that it controls the temperature without using it manually. It is very easy to install at heat dissipating devices to cool down them. Saves the energy by turn off the motor fan and normal or low temperature automatically. Disadvantages. Microcontroller is the heart of the circuit. If controller is damaged, the whole system will be interrupted. Speed control is independent of individual preference. Application. Automatic temperature control system is an important application used in almost all modern gadgets and smart homes. The systems for controlling temperature automatically is achieved by using Arduino Uno board microcontroller system. Arduino Uno, due to its increased popularity, find its varied range of applications. Courses outcome. Able to develop automatic temperature control circuit, able to connect different components to obtain the circuit, able to configure Arduino board, able to identify different I/O ports of Arduino board. Conclusion. Hence, we have developed automatic temperature control circuit using Arduino board by developing program code and using different components. Thank you.
Zeno Education Society, redefining excellence.